we're going to talk about finding the velocity. We're going to talk about finding the velocity. So I have this question here. It says, okay, well, a bat flies in a straight line at a constant speed. Okay. At 20 seconds after 10 p.m., the bat's position is 360 meters. At 30 seconds after 10 p.m., the bat's position is 370 meters. So what is the average velocity of the bee? All right. In other words, what was the velocity of the bee in that time period? Well, we know the velocity, the change in velocity is equal to the change in position over the change in time. Okay, we know that is true. And we can further this down and say the change in velocity is equal to d of my position x, my position y, my position z, right, with respect to time. And that simply is equal to dx over dt, dy over dt, and dz over dt. Okay. So that's what that means. So if I'm looking at this, initially it's at a position 360, final it's at a position 370. So therefore, if I'm looking at this, the change in position will be from R2 minus R1. So I'm going to take 370. I'm going to subtract that from 360 meters. Okay. So when I do my change in position, this becomes 3 minus 3. Well, that's just 0. Well, that's nice to know. 7 minus 6, that's 1. And 0 minus 0 is 0. So this is what we get to be our new position. So that's our change in position. Now the change in time is just equal to the t final minus t initial. Okay. So the change in time is equal to t final minus t initial. So yeah, that should mean equal sign. So if I'm looking at this, my final time is 30 seconds. I'm going to subtract that from 20 seconds. So if I'm looking at this, the average velocity, okay, will just be, well, 30 minus 20 is 10. So 10 divided by 0 is 0. Okay. And then if we divide 1 by 10, well, that's nice. You know, we get 0.1. Okay. And we divide 10 by 20, but if we divide 10 by 0, we get 0. So this will be my velocity in meters per second. Notice I'm dividing meters per second. So this will be my velocity in a vector, meters per second.